Hi, in this session now we are going to see about structure and functions. How structures are used with functions, how we are passing structures to functions. So let us start directly with an example in C programming. We already seen two sessions with structures. This is third session for the structures. So the topic here today is functions and structures, you can say. So we'll start with the start group. So there's a normal header. We have a main function return 0. So we'll just put it like this. And if you want to use structures, we have to define the structures. So as in the last session, we will be declaring the structure for student. So struct student. The members are char name. So you will have a 15 sized character array, and you will have one age, and you will have one float variable CGPA, and it ends with a semicolon. So here we will declare our structure variables. Struct student, say A. A is a variable of type struct student. So there is a structure directly. We have created a structure. A is a structure which is having three members. So if I am putting A dot name will be there, A dot age will be there, A dot CGPA will be there. So for example, I'll just put 8.5 for CGPA, age is equal to say 21, name I'm just putting strcpy, name Raj, I just put like this. So we can have values stored in this way using what operator? Dot operator. Using dot because this is a structure, this is not a pointer, it's a structure itself, structure variable. Now this A is a local variable because it is present inside the main function. So if I write some other function, say for example int fun, it returns integer, say this function cannot access this variable A. So if you try to do a assignment A dot age equal to 44, then it will not work because the age is not visible to the fun. So because it is local variable to main, so the visibility is only inside the function, or we can say the scope is only inside the function where it is declared. So A is a struct student, it is not visible here. So if I want to make something visible to all the function, but just by general rule we have to declare the structure outside. So if I declare like this struct student A, then this A is a global variable. Even here this A is a local variable. As both are different. This is a local variable, local to main. This is a global variable we have declared. This is one way to declare, or we can declare like this. You can just put A. So this is also a global variable declaration. So for example, after the definition of the structure, we have defined the variable A, or we have declared a variable A, it's a global. So in this case, struct student A is having a value 21. Now here we are just putting assigning value A of 44. So this A is a local A, this A is a global A. So what will this A be? Will it be accessing global, or what will happen? Let us see. So if I have one more A here, then for example we do a printf percentage d A dot age. If we do like this, So obviously prints print 21 because it is assigned with the value 21, no problem, because we didn't even call the function fun. So now for example I just call the function fun. I am setting a dot age equal to 44. Let us see, after I'm just calling fun function fun, then again you will try to print this age, where it is a local age or where it is local A or where it is a global A, because we have changed to 44 here. Here it is 21. So first 21 is printed in this point. 21 is printed. Now we are calling fun. Fun is setting a dot age equal to 44. Then return 0. So it comes back here. Then again I am printing a dot age. So what will be coming? Let us see. 21 and then again a 21. So this also again a local. So whenever there is a global and when overriding with the local, which gets more priority? Local gets more priority. So if there is a local, then it will be printing the local. If there is no local, for example, I am having a dot age equal to 44. Say for example, if I don't have this local, I'm just calling this fun function, then I'm printing a dot age, because since there is no, this is the only thing that is present here, so obviously it should be printing 44. I print 44 because there is no local. So if there is a local, local will override the global. That's what you have to remember. So in here there is no local A, so this A obviously corresponds to global structure variable. So there is a global structure variable, there is a local structure variable. So if I have one more variable called B, B is only just a local to main. There is no global for B. So here there are two students. One is A, student B. Here there is a student A, which is a global. So these are just variables. Struct student is a data type. User defined data type. The whole thing. Struct space student. Two words. We say it's a data type. That's what you have to remember always. So that's a fun. Now, if I want to pass the structure to a function, how will it happen? So in this case, no problem, because it's on global we have. So suppose we will just don't have a global and all. We'll just have a function, and we have a struct student A. There is a B, and we'll just remove these stuff. We have A values put up over there. The same way we can just put up values for B. Same. Then say age 22, CGPA 8.9. So we'll have like this. This is A, this is B, this is B, this is B. Two structure variables we have declared, and we have stored values in this way. We can store in some other way also. There is no need to put equal to all the time, so we can just put equal to here. We can just put things like this directly. Raj, comma 21, comma 8.5. That and all we have seen already. So in this case, the three values will go and sit in the order. The same way we can store it for B also, but now we are just following this procedure of giving hard-coded values this way. So we are just giving the values. Now if fun1, if this fun function needs these two structures which are local to main, it needs these two structures. So we are calling this fun. Now I am passing these two as the actual parameters, A comma B. So here it's a formal parameter, so it has to receive A and B. So in this case, I just have to do a struct student A comma A and struct student B. So this A, B are local to main, this A, B are local to fun. So this A, B doesn't have any relation with this A, B. This A and B are local to fun, this A and B are local to main. That means they have separate memory area allocated in the stack with respect to main, These A and B will have a separate stack memory allocated in the place corresponds to the function. Whenever the calling happens, it will allocate value to that. So this is by this way of passing, we say it's a pass by value, because both are in different memory locations. So in this case, A is passed and B is passed. It is stored in A and B, but these two A and B are different memory locations compared to these two A and B. So I can just change it to say M and M. So for naming confusion you will not be having. So M is one place, N is another place. A is different memory area, M is a different memory area, but the A values are stored in M. A has three members, Raj, 21 and 8.5. These three values are stored in M's members. Raj is stored, age is stored, but in different memory locations. So M here and N here. N will be having Kavita at 22 and 8.9. This is stored because I pass A values are given here, B values are given here. Only values are given, but the memory is different. So this is called pass by value. We say it's a pass by value. Now if I assign M dot name, M dot say age equal to 33. If I assign like this, so that means it will not reflect here. So M is the one which is passed for A. So if I do a print of say percentage %, if I am typing A dot age, so it's a pass by value. Age is having 21. I am just passing here M. So M I am overwriting with 33. So 21 is overwritten with 33 in this memory area, but not in A. In A it is still 21. So if I print in A the age, it is still 21 because it's a different copy. It's a deep copy, you can say. Just printing 21. So here it is changed, but it is a different copy. So if I change something here, it will not reflect because it is passed by value. It is not passed by reference. It is not passed by reference. So that is why different memory area, it has a meaning. So if you are passing as a pass by value, then this way you have to write. If you are passing for a pass by reference, how to do? So if you are doing pass by reference, so A and B are passed. A and B are passed. So you have to pass different. You have to pass the starting address. You have to pass the starting address of A and B. And see, it is happening like this. It happens like this. So you are passing the starting address. Ampersand means reference of operator. So reference of A, reference of B I take. I am passing these two. So since it's a reference, that means since it's an address, I have to store the address in a pointer variable. So I am just declaring it's a pointer variable. So star M and star M. Since it's a pointer variable to structure, you cannot use dot. You can use arrow. You can use arrow operation, arrow operators. This one. So age I am putting 33. So in this case, I am passing A and A's address is passed, not A is passed. You are passing the starting address of the structure. The starting address is stored here. So this M is the variable which is storing address. That address points to A. So if I change something using this M variable in this way, it is actually you are changing in this memory area, because A is the one which is having memory area of size 15 plus 4 plus 4, 24. So A is having that memory area. The starting address of the 24 bytes is passed through this one. It is stored in M. Now M will be using this arrow operation. I am just changing that value in this 24 bytes. That is in this 24 bytes the age portion. So age portion is changed to 33. So here if you print before the function call, if you print the age before the function call, it will be printing 21. after this function call, a which is pointed by m is changed to 33 for that age member. So now if I print the a.age, it is actually changed by this function through this access. So it should be 33. So first it prints 21. At this point it will print 21. After the function calling, it just goes to this place and then it changes this 33. So next time it is printing 33 in this after this pass. So this is called pass by reference. So if you are passing a structure by reference, you have to get like this: struct student star, which is for a variable, struct student star, which is for this n. I'm passing 2, but I'm not changing anything here. So 2 structures are passed and it's got as a pass by reference. In pass by reference, if you change here, it will reflect. So that's a pass by reference concept.